Holy smokes, what do I do now? Looking originally at our first circuit, our first simple circuit, we had a system that looked like I had my potential, I had my resistance, okay? And from there, I could use the idea of Ohm's law to determine how much current is flowing through that circuit. So imagine I have 12 volts here, and I have 6 ohms here. I can very quickly determine that the amount of current that's traveling through here is 2 amps. Okay? What about this? What about that? What do I do here? Well, I got a problem. So let's say my numbers are exactly the same. 12 volts, 6 ohms, 6 ohms. Okay? So how much current is flowing through that circuit? Well, the current is being released from here, and it's going, let's say, in this direction. So let's pretend that's the way the current is traveling. Okay? So countering there's the 6 ohm resistance. Well, from our original model, we could say that that current goes through there, through the 6 ohms, it gets reduced down to 2 amps. So hey, look, I've got 2 amps going through that 6 ohm piece. Okay? And then as it travels through there, it goes through there, and then, well, I got 2 amps going through there. Well, I don't know, maybe I still have 2 amps going through there. Okay? Or maybe I have 1 amp, or maybe I have a half an amp. But, you know, the idea that, oh, I'm releasing it, my current is going to drop as it goes through one resistor, current's going to drop as it goes through the other resistor. It's not true. It's not how it works. Think of the potential as being able to see the entire circuit at once. It sees that the total resistance of the circuit is over here somewhere. It's going to go through these 2 resistors. It's going to release 1 current, and that 1 current is going to travel through those 2 resistors and then return back to its voltage. Okay? It sees that. So instead of releasing all of this ampage and then having the amp step down, it only releases enough amp that's allowed to travel through both of those resistors at one time. Now, how much is that ampage going to be? Well, I want you to think about this not mathematically, well, sort of mathematically, but just think about it using this idea that the resistance is equal to the resistivity, rho, times the length divided by the area. So if I have 2 resistors that are identical, let's say they're made with the same resistivity, they have the same length, and they have the same area. So in all cases, that they're the exact same resistors. Okay? Well, in this situation, which this situation is referred to as series. So it goes through one resistor and then it goes through the other resistor. So in all actuality, isn't it going through one resistor that's twice as long? Isn't it going through one resistor that's twice as long? Isn't it going through 2L instead of that? Well, we could also express that as rho 1 resistor plus rho 2 resistors. But all I'm getting out of this is the resistance total through my circuit is equal to my first resistance plus my second resistance. That's my total resistance. Now, it doesn't seem that hard to believe, and the way I want you to think about it is that you've just basically increased the length. You've doubled the length, or in some cases tripled or quadrupled the length. But you're always increasing the length by adding another resistor into the circuit. Okay? So doing that will increase the resistance in the circuit. And it's an additive increase. It's not a product. We're not multiplying. So adding more and more resistors into there is adding more and more resistance into the circuit. Okay? Cool? So for a system that's in series, the resistance is the summative property of all the resistors in that series. Okay? Cool? Does that make sense?